Hi. So we are now going to talk about domain versus range, which I know are two brand new words for us. This whole unit, this whole module is all brand new concepts, which I absolutely love. It might not have felt like it for the first lesson, and it might not feel like it in lesson 4.4, but right now it's a lot of brand new stuff. This brand new stuff is bringing to you two new words that relate to concepts that you already very much know and love, or at least like a little bit. I mean, you're all mathematicians, you can handle it. So, domain versus range. These are very specific words that we use specifically with functions typically, but you'll get used to me asking you questions like, what is the range of this function? Or what is the range of this equation? What is the domain of this equation? On a very regular basis throughout this whole year. Domain and range are just other words for concepts you already know. Domain. If you know about domain, you know about independent variables. If you know about domain, you know about x values. Okay, domain, range, independent, or domain is independent variables, x values. You also know about inputs. In other words, it is whatever we put into the equation is what we would talk about in terms of domain. We're talking about all x values. What are the x values that we're looking at in terms of a relationship? So if I were to talk about domain in terms of this graph that we have here, this domain in terms of this graph, I'm talking about just the x values for this graph. If I look at this graph, its x values cross at 1, and they definitely are continuing on all the way through here, and then they cross here at 5. So if we were to actually even look at these coordinate pairs, I have 1, 1 and 5, 6 here. So we are talking about a domain a domain values of 1 to 5, but we also need to understand that we have like a filled in dot here versus an open circle here. So domain and range can be notated in a couple of different ways. This one is a continuous line, so I need to make sure I talk about a range of values, not just discrete points, but the range of values in this, I would say the domain is values that range from 1 to 5, and I'd say 1 is less than or equal to x, because domain talks about x, and if we ever want to think about that a little bit more solidly, so we know x is on the ground, just like pirates, x is on the ground, y goes up and down. Domain, in terms of that, I also like thinking about kings and queens. Kings and queens rule a domain, and so they're talking about all the land, typically. We all know that x is on the ground, pirates, kings and queens, like it all kind of goes together, right? So x is on the ground, y goes up and down. Domain is the domain that we were ruling, so we're talking about horizontal stuff. So the horizontal stuff that we're looking at is 1 is less than or equal to x, and we know it's less than or equal to x because that's a closed circle. Here we have an open circle, so we're going to just have a less than sign. We're going to write 5. So my domain in that situation for this continuous function is a range of values from 1, which is less than or equal to x, which is less than 5. If I was talking about discrete points, if this was just a bunch of points here instead of a continuous function, if there was just some dots, then I would be writing this a little different. If this were dots, I would be looking at something like this. I'd say domain is a set of points, maybe 1, 2, 3, 4, and 5, and that would be my domain. Okay, my domain is this set of points. And if I had that, I would literally have dots instead of a line. Continuing on. Range, so if domain is our independent variables, our x values are input, range then is exactly the opposite of that. So our range is our dependent variables. Our y values, our outputs. So that's essentially, we're talking about all of these vertical parts. So all of the vertical parts. So if I was going to, again, notate this, I would be talking about the vertical stuff. And so I literally, when I do this sort of thing, oh my gosh, my lines are horrible. When I do this sort of thing, I will literally draw out on my graph or whatever, and I will draw horizontal and vertical lines to say, okay, this is sort of locked in vertically on these points. It's locked in horizontally on those points. Does that make sense? It's really important for me specifically to see that visual, because otherwise I have a really hard time conceptualizing this stuff. So I have 1, 2, 3, 4, 5, 6. So this set of points is a continuous function that I'd write R for range, my range values. So I'm talking about Y values range from 1 to 6. And 1, because it was a filled in dot, is less than or equal to Y, which is less than 6, because it's a fill, or it's an open circle. Again, if I were talking about range in terms of discrete points, if these were points plotted instead of a continuous line, I would write something like this. Range is brackets, -2, -1, 4, and 8, and bracket. It's not the points in between any of those numbers, but the range values that I would get from some of these points or whatever, -2, -1, 4, and 8. Now understand, my domain values, the number of domain values I have, do not need to be exactly the same as the range values, and that's okay. That will help us determine whether or not we have a relationship or a relation versus an actual function, if our domain and range values are different from each other. It all kind of helps us figure that out. All right, so domain versus range, we're talking about X values versus Y values. One more video after this talking about what is a function. Hopefully it will clarify a lot of this stuff for you. And if it doesn't, I expect you to send me emails and ask me questions. Thanks for watching, and don't forget to watch the next video. Bye.